Alright, so model 23, differentiation applied to a combination of different functions. And by this I mean we can have an exponent to a power, we can have ln with something, or two functions being multiplied, or in the final case, two functions being divided. So we'll look at how we deal with all of these cases separately. So first of all, whenever you have an exponent with a power, it gets multiplied by the differential of the power. In this case, the differential of sin x is cos x. Thus, y dash is going to be e sin x as it is multiplied by the differential of the power. And our final answer is going to be cos x multiplied by the dot represents a multiplication. And this is our final answer. Moving on, what is up? We have ln with something inside. Ln with a trigonometric function inside in this case. So the differential is going to be, the steps are, whatever is inside ln goes down. So cos x goes to the denominator, and we are going to multiply this fraction by the differential of whatever went down. In this case, it's cos x. Thus multiply by the differential of cos x, that's sin x. So we have y prime, no, y dash, my bad, is equals to minus sin x over cos x. We can further simplify this. So our final answer for the differential is going to be minus tan x, since sin x over cos x is tan. Then we have two functions being multiplied. In this case, we'll apply the product rule. So x being considered as u and tan x being considered as v. Write these down separately. So u is equal to x and the differential of u is equals to 1. v is equal to tan x and the differential of v is equals to sec square x. As we learned before, the formula for product rule is as follows: dy over dx u into v prime plus u v dash, uv dash plus vu dash. Substitute the values. This gets multiplied by this and this gets multiplied by this, leaving us with x sec square x plus tan x into 1. Multiplied by 1 is going to be the same. So this is our final answer. Moving on to our last and final example, where we have sin x over cos x, two functions being divided. Now first of all, notice sin x over cos x is equals to tan x, right? So we can write down this as tan x, and the differential of tan x is sec square x. So we should expect the answer should be sec square x, but in this case, let's not choose this approach. However, we can confirm the answer using this. So we have the differential as vu dash minus u v dash over v square. If you're wondering what this is, we are applying the quotient rule, since we have two functions being divided. So we have u as sin x, u dash as cos x, v as cos x, and v dash as minus sin x. So first of all, v u dash, these things get multiplied, giving us with cos x into cos x. And we have minus this, that's gonna be sin x into minus sin x. Everything over v square, that's cos square x or cos x whole square. So we have cos square x. This is gonna turn out to be minus sin square x. Just simply write this as cos square x plus minus cos square x plus sin square x over cos square x. We know that this whole thing is gonna turn out to be 1, and the denominator remains as it is. So we know that 1 over cos is equals to sec x. Thus, simplifying this further, we have sec square x. And this is where we wrap things up. We looked at exponents with the power, ln with a function, and two functions being multiplied and two functions being divided. No more examples. You guys have to practice this yourself. I give you the concept.